In this video, we'll discuss about domain and range of a function. The domain of a function is the set of all valid inputs in a function. So that is all inputs that are valid to be put into the function. While the range is the set of all possible outputs that we can have for a function. So whenever we put the inputs, what are the all possible output that we can get for that function? Our first example for domain and range is this, to find the domain and range of this function. So if you look at this function, we are given the domain that our values of x should be from from 1 to 3, and 1 and 3 included. So you have to just make sure that can we substitute all these values? Yes, we can substitute them here. So therefore, our domain will be this from 1 to 3. To find our range, we have to find what are the possible output that we can get. So we can start by computing f of 1, start with the 1 in the domain, which will be 2 times 1 minus 1, and this will be 2 minus 1, which is equal to just 1. Then we compute f of 2. This will just be 2. Then instead of x, we put 2 minus 1, and this will be 2 times 2 is 4 minus 1, which is equal to 3. Then the next, we can compute f of 3. This is 2 times 3 minus 1, and this will be 6 minus 1, and this will give 5. So we can see our values are increasing, and we have from the smallest one is having 1, the greater one, the bigger one is having 5. So we can see our range is this interval from 1 up to what? 5. Not that we can also substitute f of 1.5, f of 2.5, as long as they are in this domain 1 to 3, and the range that we'll have will be in between this 1 and 5. So in this example, we want to find the domain and range of the function f of x equal to 1 over x minus 4. So if you look at in this example, we are not given the domain. So we could think that the domain should be maybe something from minus infinity to infinity, but this has a restriction in general. So the restriction, two cases. First, if we have a fraction, we want the denominator to not be equal to 0. And the second is that if we have a square root, in this case we want the radicand to be greater than 0. So radicand is just what we have, what is inside under the square root. So for instance, if we have square root of x plus 1, so the radicand is just this x plus 1. So this is the radicand. So this is in general what we have to do. So let's look at this example. We want to find the domain and the range of the function f of x is equal to x minus f of x is equal to 1 over x minus 4. So as usual, let's write it first. F of x is equal to 1 over x minus 4. But for this case, we want that this x minus 4, we want it not to be 0. So we want x minus 4, which is our denominator, to not be equal to 0, since it's a fraction. So if it's not equal to 0, then we want it to be, we want this x minus 4, we want it to be greater than 0, or x minus 4 should be less than 0. And in this case, we have that x is greater than 4, or we should have x is less than 4. So we should have either x is greater than 4 or x is less than 4, but it shouldn't be 4. So, and using number line, this one is x should be greater than, this is, we have 4 here, so x should be greater than 4 up to plus infinity, or it should be less than 4 up to minus infinity. And this one in general, we can write our domain as minus infinity up to 4, that is x is less than 4, union from 4 to infinity, that is greater than 4. And you see that we use the rounded bracket to show that the 4 is not included. So this is our domain. So to find the range, we should think of things like range. So we should think of something plus, minus, and 0. So what we should think of is that, remember that range is the values that we can get when we put the domain as an input. So what values are all the possible values that we can get from this function. So let's look at, can we get a positive? Suppose I put if you put instead of this x, in this x we substitute 5, so we'll get 1 over 5 minus 1, which is equal to 1 over 5 minus 4, which will be equal to 1 over 1, and that is just 1. So we can have positive. Negative, I can choose this x to be 0 or minus 1. So if I choose this x to be 0, I will have 1 over minus 4, which is negative. So we can also have negative. But can we have 0? No, because for us to have 0, we have to have a 0 divided by something, but we have 1 here. So we cannot have 0. So we can see our range is, we can have all in the real line except 0. So our range will be from minus infinity up to 0, union from 0 to infinity. So only 0 is excluded. In this example, we want to find the domain and range of the function f of x is equal to square root of 4x squared minus 1. So as usual, let me start by writing the function first. F of x is equal to square root of 4x squared minus 1. So if you look at this function, we are having, as we said, whenever we are not given the domain, we know it could be minus infinity to infinity unless we have a restriction. If it is a fraction, we don't want the denominator to be 0. If it is a square root, if you have a square root, we want to make sure that the radicand is greater than or equal to 0. We want to make sure, since we have square root here, that the radicand, that is what we have under the square root for x squared minus 1, should be greater than or equal to 0. So for this case, so we want to make sure that 4x squared minus 1 is greater than or equal to 0. To solve this, remember how we solve it in the inequality. So what we have to do first is to solve 4x squared minus 1, and we just assume this equal to 0 and solve this. So to solve this, we have minus 1 here. Since we want to find x, we just add 1 to both sides, and this will be 0 plus 1. Then we'll have 4x squared minus 1 plus 1 will give us 0. So 0 plus 1 will just have 1. Now we want to find the x, so we just divide both sides by 4. Divide this by 4. And 4 goes into this 4 just once. So we'll have 1x squared is equal to 1 over 4. And from here we'll have x squared is equal to 1 over 4. And from here we can take the square roots into the right hand side, which will give us square into right hand side, which will change to square root of 1 over 4. And this will just change to x equal to plus or minus. If we have this, we can just write it as square root of 1, square root of 4. And this will just be plus or minus. Square root of 1 is just 1, and square root of 4 is 2. So x is plus or minus 2. So I told you that we call this the critical points. So then the next thing is, remember, if you have y equal to 4x squared minus 1, since the coefficient of x squared is positive 4, then we have a U-shape curve that intersect the x-axis at minus 1 over 2 and 1 over 2. So we'll have something like this. Maybe this is 0, this is 1 over 2, this is minus 1 over 2. So our curve should the intersection here should be at 1 over 2. Should intersect this at 1 over 2 and minus 1 over 2. Then we look for so since here we have our 4x squared minus 1 is greater than or equal to 0, we want to find the place that this curve, the x values where this curve is over the x-axis. So that is all these places. So we want all this all these places. So then from here we can see that here we have anything that is less than minus 1 over 2, that is maybe somewhere here, minus 1 over 2 up to minus infinity, and here we have a plus here is here minus 1 over 2, and here is here 0.5, here up to infinity. So we have anything here is from minus infinity up to minus 1 over 2, but we have to use square brackets since it is less than or equal to, and for the other one, union, anything here from 1 over 2 up to infinity. That is, we can just say x is less than or equal to minus 1 over 2, or x is greater than or equal to 1 over 2.